Hello and welcome to the Spotify analysis project for Industrial Engineering 142, where we share the process of building a model that predicts the next biggest hit. And so what we're going to go through is first an introduction, the motivation for our project, the data set we're working with, the data cleaning process, and our models, and conclude with our summary. So as an intro for our project, what we are essentially building is using machine learning models on Spotify data in order to predict how successful a song will be before it is released. Our motivation is very simple in that we are 4 music lovers, and this helps us to personally gain a better understanding of why we like certain songs and what makes certain songs popular compared to others. And it's useful for artists as a reference to try and make it big. And since producing the next biggest hit is one of the biggest priorities of the music industry. And so the data set that we're working with was imported from Kaggle with 3 main data frames, namely tracks, artists, and dictionary of artists. And what we essentially did was we joined the track and artist data frame in order to obtain features specific to a track, which are the independent variables that we're interested in, and the corresponding artist information, which is the dependent variable that we're interested in, namely popularity. And for the independent variables or features, there are a total of 20 columns in the data set. And so from the track CSV file, we were able to get a wide range of features specific to each track. And to summarize, there are 11 numerical variables and 2 dummy variables and 6 categorical ones. And as for our dependent variables, it is the popularity of an artist based on all of his or her tracks. And the distribution of popularity is from 0 to 100, and the mean is around 25. And using the mean, we are able to put popularity and transform it from a continuous variable to a binary variable, in that above average would be popular and below will be considered unpopular. As for our data cleaning process, the numerical variables were already very helpful and readily available for our model composition. And so basically what we did was we changed all the categorical variables into binary ones for the easier composition of our model. So we changed release date into 4 seasons, the artist collaboration into a dummy variable, with 1 being there is collaboration and 0 being no collaboration. And the name categorical variable was too much to do 1 hot encoding, and so we limited to the name length, which was a numerical variable. And using NLP, we also included the top 8 most frequently used words in song names to see if there is a correlation. And moving on to our model design and the models that we've tried to predict the popularity of a song. So first we did a logistic regression with around 30 features to predict the popularity of the song, and the accuracy was 75.5%. And for the LDA model, we had 78% accuracy on the test set with an area under the curve of 83%. And for our CART model, the best CCP alpha is 0.002, and with a node count of 23 and an accuracy of 86% and a precision of 84%. As for our random forest, we fitted the training data to random forest regressor of 500 estimators with an accuracy of 88%. And with boosting, we did significantly better in that the accuracy was 91% with fitted training data to gradient boosting classifier of 50 estimators. And so for the conclusion, the accuracy was lower on LDA and logistics, which was pretty within expectation in that they're lower in complexity, and the accuracy increases when we incorporate models of higher complexity. And in the future, we will include blended model. And since it is constrained by our machine processing power, it wasn't strong enough for the large size of the data set in order for it to be included in this video. Thank you.